NextPCB is a leading provider of reliable PCB fabrication and assembly services for engineers, startups, and businesses worldwide. Specializing in quick-turn prototypes to mass production, we offer multi-layer, HDI, flex, rigid flex, and metal core PCBs with strict quality control and superior customer care. Our advanced facilities ensure reliable performance for applications across consumer electronics, automotive, medical industries, and more. Embracing Industry 4.0 digitization, we streamline the entire electronics manufacturing process to give you competitive pricing and fast lead times, without compromising on quality. And our user-friendly online platform provides instant quotes, order tracking, and full transparency. In addition to PCB fabrication, NextPCB offers comprehensive PCB assembly services including global parts procurement, testing, certification, and box builds. Our 36 automated assembly lines include advanced inspection tools such as SPI, ALI, and X-ray, reflecting our commitment to quality and reliability. Choose NextPCB for exceptional electronics manufacturing solutions you can depend on.
You can see the NextPCB link by going to the More under this video. Click that, scroll down, and right here is check out our sponsor, NextPCB. Thank you. Okay, we're going to begin with creating a Jameco 20626 adjustable dual power supply kit. So we need to go to Jameco to get this kit. We're going to open Google. We're going to navigate to Lab, Rats, Engineering, Tutorial. Click on that. We'll bring up the Lab Rats Engineering Electronic Tutorial channel. We're going to go to Custom Links. Here you got a link to our website. This is our PayPal donation site. If you would like to help with production, any amount of donation will be greatly appreciated. Next site is the Jameco site. I'll click on the Jameco link. This comes up to here. You can see it's Jameco. And then we type in 20626. That's our model number. Here's that power supply right here. It's currently on sale. Click that. For $27.96. This is December 2025. So it's probably just for Christmas. This is what we're going to build. So we will go ahead and order it, set it there, and pay for it how you will. And when you receive it, open your box and then come back to this video and we will assemble the power supply. We'll go over all the different components. We'll use our oscilloscope to see the signals as we construct this supply. And it'll be a great addition to what we've already covered, but you'll actually get to see it and use your test equipment to test it out. All right, thanks. All right, we just received our kit from Jameco through the UPS. Thank you, UPS. So we're going to open it up. We got to take an inventory. You never know if they left something out. Wrapping. Here's our parts, our transistors, LEDs, resistors, potentiometers. There's our AC cord. Our power transformer, very important. And here is our instructions. Here's our circuit board. As you can see, it's one-sided. Right there. And here is our assembly instructions and with our inventory. So let's go through the inventory. Okay, now let's do our inventory. We've laid everything out onto our workbench. Our LM317T is our positive adjustable regulator. This is our LM337T, which is a negative adjustable regulator. Here's our heat sinks that go with that. They're THM 6030s. Our 2.5K ohm potentiometers, quarter watt each. Here's our 1M4001 silicone rectifiers for making our 4-wave rectifying bridge. Here's our two caps, the outgoing caps, titanium caps, which are 1 microfarad, 35 volts. Here's our electrolytic bulk capacitors, which are 22,200 microfarad, 16 volts each. 1K ohm resistor, we only need one, but they gave us several. And then 180 ohm resistors, which we need only two. They gave us several. Here's our red LEDs. We only need one, but we got several of those, so that's nice. Add that to the collection. And then assorted screws and nuts to assemble the board and hold the transformer on and the heat sinks. So, to the regulators. Okay, so that's the inventory. Oh, we also got a transformer and our 6-foot electric cord and our instructions. So we're going to go through the instructions and put this thing together. All right. Okay, since we just completed our inventory and we got all the parts we need to complete this kit, let's go over the assembly instructions just a little bit. We have a model 20626, a dual power supply with independent adjustable positive and negative output voltages. They both have a separate adjustment, provides the user with an unlimited application for IC circuit voltage requirements. This power supply may also function as a versatile general purpose variable power source. Specifications is voltage range is from 1.2 volts DC plus or minus to 15 volts DC plus or minus. The assembly specs say that the power at 5 volts DC at 500 milliamps or 10 volts DC at 750 milliamps, 12 volts DC at 500 milliamps, and 15 volts DC at 750 milliamps. That does not mean you can't have 7 volts or 11.5 or 13.4. And I think from our past experience on the Tech Talks, we know that both these supplies, voltage regulators, can put out 1.5 amps before they start shutting down from thermal overload, which tells you that they have thermal overload protection. Heat sink regulating cooling. As you can see here, this is the kit that we're building, and we're going to build it section by section. So let's go over here to this. Okay, so the instructions suggest to simulate board assembly by placing the components in their actual place on the picture assembly seen in Figure 1 or Figure 3. So those are down here. This is Figure 1. As you can see where all the diodes go, where the cathode goes, the anode goes. You can see where the transformer goes. And you can see the center tap, which would be the red wire, and the blue or black wires here and the blue wires here. And this is the two yellow input wires of the transformer. Don't cross them. Okay, then Figure 3 is right here. It gives you a better example of how the regulators will go in and which way they need to face. And here's how the wires should look as well on a transformer. And then here's the AC cord in. Here's your jumper that will be jumping later. Okay, so, but since we are going to assemble the power supply by sections, we will not do this, but once a section is completed, we'll do section by section, not the entire thing. We will use our oscilloscope to analyze how this section affects the power supply is converting of the 120 volts AC to a smooth filtered DC voltage. This is going to be fun. Hopefully you'll enjoy it. Some of the tools that you're going to need is you're going to need a small soldering iron, 27 to 35 watts. I have a Weller model number WLC100, which is a 40 watt, 120 volt, 60 cycle soldering iron. You need rosin paste flux. SP44 is what I use. You need to flux to clean the metal so that the solder will stick. Resin core solder, SN60 or SN63. I have SN63. Small sponge, water damp for cleaning the tip of your soldering iron. Small wire cutter and stripper. Small long nose pliers, a slot screwdriver, pair of pliers, plastic electric tape, a digital voltmeter, an oscilloscope with probe, small bench vise to hold your board, or you can lay it flat, plus a ground buster to plug your oscilloscope into, so you don't, when you connect the ground, we'll be able to connect the ground anywhere we want, and it won't blow the fuse. Okay, so now let's take our printed circuit board, and we're going to prepare the transformer and the voltage regulators. Here's the transformer. This is black, center tap, blue, as you saw there. Now the wires on the transformer are all 8 inches long. We're going to reduce them down to 3.5 inches in length, strip a quarter inch of the insulation off, twist the bare wires, and then tin the wires. That'll be on the input and the output wires. Considering the ICs, the voltage regulators, we're going to say this is pin 1, pin 2, pin 3. We're going to bend the pin about a quarter inch, as you see in the picture, away from the chip for pin 1 and away from the chip for pin 3. And then when we try to install these into the board later, you'll see why we did that. So right now, we're going to get our diodes, our 1N4001, get 4 of those, and we're going to assemble those onto the board and assemble the transformer onto the board. And then as you observe how that changes the AC signal because of the components put into the circuit. That'd be kind of cool. Okay, we've got our camera set up. So we've got a varactor right here. This is a really nice tool to increase voltage slowly on something you're working on so you can see if it's shorted or not. But it's a 0 to 120 volts AC. We have our oscilloscope over here set up on 500 millivolts. It's a ×1 probe. So it's gonna show us our pulsating DC. We're coming off the positive side of the half-wave rectifier. If you have any questions about that, put that in the comment and I will write you back. And so we're going to kick this up to 120 and we're going to watch the pulsating DC come out. Right there's 120 volts. You can see the pulsating DC coming out of the power supply just like the simulation. Okay, that's it. That ends part A of a 4-part series. The next part is going to be part B, where we will be adding the bulk capacitance and seeing how that bulk capacitance converts the pulsating DC to a filtered DC with a very small 120 hertz ripple riding on the DC RMS value. Be sure you check out our description box below this video. Check on the link for NextPCB. NextPCB is our sponsor, and NextPCB is your comprehensive solution for all your printed circuit board needs. On the More button, you'll get our mission statement of what our purpose is and what we're trying to accomplish. A link to our webpage where you can buy all kinds of cool stuff from the geek shop and used and new test equipment. You can help replenish our coffee fund by donating. We'll take any kind of donations. We have Jameco Electronics. That's where we buy our parts and some of our kits that we make. And then NextPCB, it's our sponsor. They have the answer to all your PCB needs.